Our next application of logarithms is the Richter scale, which you've probably heard of in relation to judging the magnitude of an earthquake. So, description here for us from our textbook says the Richter scale magnitude R of an earthquake is R equal to the log of A over T plus B. So what we're doing is we're comparing the amplitude in micrometers of the vertical ground motion at the receiving station to T, which is the period of the associated seismic wave in seconds. And then B accounts for the weakening of the seismic wave with increasing distance from the epicenter of the earthquake. So we're going to use this model here to answer the question down below. It'd be similar to something that you might have to do as you work through logarithmic equations. So how many times more severe was the 2013 earthquake in Pakistan, which measured 7.7 on the Richter scale, than the 2011 earthquake in Japan that measured 4.7 on the Richter scale? Well, here's what we're going to do, is we are going to set up and compare the difference between these two things. So I'm going to write out a logarithmic equation. It looks something like this. First of all, I'm going to have this equation, log of A over T plus B, for both of these. So we're going to have the log of the A of T, so we'll call it, from R1, we'll just go A1, compared to T plus B. We're going to subtract, we'll put this whole thing in parentheses, so this is going to be one particular value minus a whole other value, which is the logarithm of A2, whatever the amplitude is, over T plus B. And I know that that's going to be equal to the difference between the two numbers that I was given. It's going to be equal to 7.7 minus 4.7. Okay? So algebraically speaking, we're going to break this up. We're going to simplify a couple of things. So first of all, I have the logarithm of a quotient, which using the quotient property of logarithms, I could say is equal to the log of A1 minus the log of T plus B. And then I have the log of A2 minus the log of T plus B. And again, remember, I am subtracting one of these from the other. Now, log of A1 minus log of A2, well, that's going to be the next thing that I write down here. Log of A1 minus the log of A2. And then I've got the opposite of log T minus the opposite of log T. What happens is those two things are going to cancel each other out. And B minus B, well, that's also going to cancel out. So that's not going to be there anymore. So log of A1 minus the log of A2 is equal to 7.7 minus 4.7, which is 3. So let's continue to work with our logarithmic properties here. I'm going to go ahead and combine these two things into one logarithm. So I'm going to have, again, using the quotient property, but now condensing, I have the logarithm of A1 over A2. So I'm comparing one magnitude to the other, and that's equal to 3. So as I solve this logarithmic equation, go away. As I solve this logarithmic equation, that's equal to 3. I'm going to go ahead and raise both sides to an exponent with a base of 10. 10 to the log of A1, A2 equals 10 cubed. Well, I do that because A1 over A2 is what I'd be left with when I take 10 raised to the common logarithm of that. So A1 is to A2 as 10 is cubed. Well, 10 cubed is 1,000. So this is essentially our answer. When we say A1 comparing it to A2, when we take those two things and combine them or compare the two of them, A1 is 1,000 times stronger than A2, meaning of these two earthquakes, the 7.7 that happened in Pakistan is 1,000 times stronger than the 4.7 earthquake that happened in Japan. Now, this is a lot of algebra work to get to the point. Might show you another easier way. If you're comparing Richter scale numbers, the easiest way to do this is just subtract the two of them. So 7.7 minus 4.7, well, that's a difference of 3 on the Richter scale. And if it's a difference of 3 on the Richter scale, well, the Richter scale is a logarithm, a common logarithm at that. It's where I have a base 10 raised to a particular power. So the difference between them is going to be 10 raised to whatever power I end up with. So 10 cubed, so it's 1,000 times stronger. If I had something else, like maybe I had an 8 on the Richter scale compared to a 6, well, that's a difference of 2, which kind of like an order of magnitude thing. That means it's 10 squared or 100 times stronger than the other earthquake. So it's just a quick look at using the Richter scale and how it connects to the idea of logarithms and solving some logarithmic equations.